This question is on application of integration, and in particular how to determine the area between two curves. Okay, so this problem has two parts. First is to sketch the region bounded by the curve y is 10 minus x squared and the curve y is 2 plus x squared. So effectively this means that if this was in a calculator paper, you're expected to know how to sketch these graphs. Okay, so these are simple quadratics that we can sketch easily. The second part requires us to find the area of the region bounded by these two curves. All right, so let's see how we answer this question. First, we need to know how to sketch the graphs. If we are going to sketch them, we need to know certain obvious properties of quadratic curves. All right, let's see. And so we have two curves. One, I've decided to name them y1 and y2, doesn't really matter. So the first one is 10 minus x squared, the other one is 2 plus x squared. Looking at this, we know the coefficient of x squared is negative here. So given a general quadratic, which we normally write as y equals ax squared plus bx plus c, right? So that's the general quadratic equation. We know if the coefficient of x squared is negative, then the curve faces upwards like that, right? So we say it's concave down. If a is positive, then it's concave up. So we know that this is concave up and this one is concave down like this, right? So the first one is concave down like that. The second one has to be concave up. Okay. Secondly, we know if the middle term, the term containing x, does not appear, like in our cases we don't have the term containing x, then we know that our quadratic functions will be, if we draw the graphs, they will be symmetrical about the y-axis, and the peak is going to be the point y is 10 and y is 2. Okay. Also, because this is a concave up and the lowest point is going to be 2, or what we call the vertex is at y is 2, we know that this graph is not going to cross the x-axis. This one is going to cross the x-axis at the point with coordinates root positive and negative root of 10. All right, like that. So some very basic pieces of information about the curves that we can tell becomes useful. All right, so let's just go in. I will list those properties that you normally need to look at when you're sketching these curves involving quadratics, and then we'll just sketch them. Okay, so some of the things you need to know about these quadratic functions is that for y1 and y2, so y1 is symmetrical about the y-axis. We know that because the term containing x is missing, the same as that. All right. The second thing we need to know, we have a maximum stationary point. That means this has got is concave down, so the highest point is the maximum stationary point, of which occurs at 0, 10. All right, this one has got a minimum stationary point, which occurs at 0, 2, like that. So the y-intercept, which is the stationary point, also 0, 10 and 0, 2. What else do we need to know? This one crosses the x-axis, so it has got zeros. This one does not have zeros. Okay, that's all you need to know about these curves, and now you can sketch them, right? All right, so let's see how these graphs look when we sketch them. So at the intersection point, we know that if these two functions intersect, then at their points of intersection, y1 must be equal to y2. So let's draw the graphs. Here are the two graphs. There is y1 and okay, with the maximum turning point, okay, crossing the y-axis at 0, 10. Here is y2, okay, with the minimum turning point, crossing the y-axis as 0, 2. All right. At the points of intersection between these two curves, at the points of intersection, y1 must be equal to y2. So if we equate those two functions, we can solve to find the x coordinates of the point of intersection. So equate the two and rearrange, we get, right, so minus x squared goes to the other side and we have twice x squared. 2 goes to the other side, subtracted from 10, which is 8. So 2x squared is 8 and x squared is 4. So x is plus or minus 2. In other words, the two graphs cross at the point at the value of x of positive 2 and at a point where the value of x is negative 2. That is referring to that point there and the other point there. And so if we are going to look for the area enclosed by these two functions, that means this area here, if we are going to look for that, then we have to integrate from negative 2 to positive 2 of these two areas, right? So we'll take the area of y1 all the way to the x-axis and subtract the area of y2 all the way to the x-axis, right? So if we subtract those two areas, we'll find the shaded area, okay? So to find the integral, we'll integrate from negative 2, which means from this point here, to positive 2, which is there, of y1. We'll integrate that. Integrating means looking for the area under the graph between, integrating between minus 2 and 2 means looking for the area under the graph from x equals negative 2 to x equals positive 2. All right, but we get the area of y1, which is from up there all the way to the x-axis, and subtract the area of y2, which is the lower curve all the way to the y-axis. So if we subtract those two, we remain with that shaded area there. Okay, that's what we are effectively doing. So if we do that, the rest is straightforward. y1 minus y2, if we subtract those two, it should be straight. You can see that that's the integral we get when we simplify. Let me just do that quickly before we move on. So y1 minus y2 is effectively 10 minus x squared, and then we say we are subtracting 2 plus x squared. That is 10 minus x squared minus 2 minus x squared, and that gives me 8 minus 2x squared. And that's so this is the effective value of y1 minus y2. So this is what we are going to integrate with respect to, okay, from minus 2 to 2 dx. This is what we are going to integrate, and if we do that, the area we find is the area of this shaded region there. So let's do that. Okay, so that's what we are integrating. If we do that, we get the integral of 8 is 8x. The integral of that is 2x power 3 over 3, like that. And we integrate from negative 2 to positive 2. And when you do that, please try it out so that you're sure. You should get 64 over 3, which is also equivalent to 2 decimal places. 21.33 should be the area under that function. Okay, the area enclosed by the two functions. All right, see you in the next question.